Now we are going to investigate or explore the relationship between the number of sides and the sum of interior angles of a polygon. So number of sides and the sum of interior angles of a polygon. What's the relationship between these guys? So what you're going to do here is to divide each polygon into triangles. So this is the strategy that you're going to use by drawing diagonals from one vertex. A vertex is this point. This is what we call vertices, right? So this is what we call a vertex. So what you're going to do is we are going to divide each polygon into triangles by drawing diagonals from one vertex, and then using that strategy we should be able to know or to find out the sum of interior angles of each polygon. And then we'll use that pattern to come up with a formula for the sum of interior angles of any polygon. So let's start. We know that, of course, let me start with the number of sides. Probably that's the easiest column to fill in. So for a triangle, we have 3 sides. Then we have quadrilateral, 4 sides. And then pentagon, we have 5 sides. Hexagon, we have 6 sides. Heptagon, we have 7 sides, and so on and so forth. Now, the next thing that I'm going to do here is to try and find the sum of interior angles of each of these polygons. And for a triangle, it will be easy for us because we know that sum of interior angles of a triangle is 180, so I'll just say it's 180. For a quadrilateral, what I'm going to do is I'm going to divide it into triangles by drawing a diagonal from one vertex, so from here to there. And then what I'll end up with is 2 triangles. So this is the first triangle, and this is the next triangle. Now, of course, you can see that the angles in this triangle, the first triangle will be 180, and here it will be 180. So the sum of interior angles of this quadrilateral will be 2 multiplied by 180, which will give us 360 degrees. I'll do the same thing for this pentagon. So I'm going to draw a diagonal from one vertex and also another one. Now I have 1 triangle, 2, and then 3. So I have 3 triangles. And I know that the sum of interior angles of each triangle is 180. So the sum of interior angles of a pentagon will be 3 triangles, and each triangle is 180 degrees to make it 540 degrees. And then in the hexagon, I'll do the same thing, divide it into triangles. And remember, I'm drawing diagonals from only one vertex. So here I have 1, 2, 3, 4. So I have 4 triangles. And the sum of interior angles of each triangle is 180. So total sum will be 4 multiplied by 180, which should give me 720 degrees. And the same thing for a heptagon. So we have 1, starting from here, 1, 2, should be a straight line. Just move up a little bit. So again, you can notice I have 1, 2, 3, 4, and 5 triangles. So sum of interior angles will be 5 multiplied by 180, which will give me 900 degrees. So the sum of interior angles of heptagon will be 900 degrees. Now I just want to go back up and look at a pattern. Now remember, this was the first triangle. It's just one triangle. Of course, 180 multiplied by 1 is just 180 because you have one triangle. Now I want to look at a pattern here. The relationship between the number of triangles and the number of sides. You can see here it's -2, -2, -2, -2. Okay, and if you keep going, this will be -2 as well. And for an n-sided polygon, that will be n minus 2 multiplied by 180. So which means that the sum of interior angles of an n-sided polygon is n minus 2 multiplied by 180, where n is the number of sides. So you can go ahead and write the formula here below, that sum of interior, so therefore sum of interior angles of a polygon is equal to n minus 2 multiplied by 180. All right.